Welcome back to week 4, and in video 4 we're going to continue on with groundwater. So what we're going to talk about specifically is what groundwater is and how it moves, and then we'll talk a little bit about how it erodes and how it creates landforms. So what is groundwater? Well, it's water that exists in the pore spaces in a rock or the soil or a sediment that's located below the Earth's surface. And pore spaces basically just means the empty spaces in that substance. And how does groundwater move through the rock and soil or sediment? Well, it depends on the porosity and the permeability and the elevation change. So how it moves, well, if we have a rock that has a high amount of pore space, so here we've got a couple different examples. We've got loose sediment here that has a lot of the white space, which would be the empty space in it, so high percent porosity. Lots of water can be stored in that rock. Moderate in the second one because we have that sediment that's compacted, not as much free space. And these last two here, we don't see any of that white free or open space, so there's to be low to no pore space at all. So a rock has to have significant pore space to actually be able to hold water and to be able to transmit it. Now the transmission, the movement of water, depends on how well connected those pore spaces are. And that's permeability. So it's the ability to transmit water from one place to another. So in this case here, you can see these little red arrows are showing you that, yeah, those pore spaces are well connected and the water can easily flow from one place to another. Whereas in this bottom picture here, those pore spaces, the white spots, aren't connected, and then the water is not going to be able to flow through that substance. So our permeability is how connected those pore spaces are. So if there's a lot of nice pathways, lots of fractures in the rock, we can transmit water pretty quickly. But if there isn't, things like clays and well-cemented sandstones have much lower permeability. So overall, the rocks that have the highest porosity and permeability, the best body of rock to be able to hold and transmit water would be sandstones, or just sands and gravels would be good ones, and then well-fractured igneous rocks, so things like basalts we have in the gorge. Those basalts have lots of fractures in the columnar jointing, so can transmit water quite nicely. So how does groundwater erode and create landforms? Well, the erosion and transportation and deposition of sediment is actually the microscopic level. So we have groundwater dissolving the rocks. And usually that's going to happen in limestones. This is the most common rock that's susceptible to groundwater erosion. How does it shape the landscape? Well, we have erosion of the subsurface or surface very, very slowly over time. So how does that dissolution work? Well, if you think back to the chemical weathering section of sedimentary rocks, you remember we can have dissolution happening. If we have water and carbon dioxide combined, we get what's called carbonic acid, which is a weak acid. This weak acid can then dissolve the rocks and break those rocks down. Specifically limestone, the calcium carbonate, that acid is going to dissolve and break the calcium away from the carbonate ion, and when we end up with the dissolved ions in the water. So then those ions can be transmitted through the pore spaces from place to place, and then when we get into an area where maybe we can have water evaporating, such as in a cave environment, the water evaporates out and the calcium and the carbonate ions can then rebond with each other and form calcite. So we have that deposition happening. So some of the landforms that we see features such as caves, sinkholes, and karst. So caves, a lot of people know what caves are. So they're basically a void space in underneath the ground. And here you can see an example of limestone that has some fractures in it. Those fractures are pathways for the groundwater to flow along. And as that groundwater is flowing, it's also eroding and dissolving away those rocks. And so we end up with caves that can form. We get sinkholes forming when those caves get big enough that they can't support the weight of the land above them, and so it collapses and creates these depressions. And then karst is the name for the topography left behind from groundwater erosion. So we can have karst topography be places that have sinkholes everywhere, and it can also be places like in China where we have pretty big karst features. So let's look at Google Earth here. So if we want to take a look at sinkholes in Florida, we zoom over, and if you Google this, you can see some pretty amazing and scary pictures. So here's Florida, and all these dark dots are sinkholes. If we zoom in here, you can see those sinkholes are filled with water, and that's because the water table is pretty close to the surface. And you can also notice some of these depressions here aren't filled with water, but you can see that they are low points in the topography. You can also look at some karst topography over here in Puerto Rico. And here what we see is we can see these high kind of pointy features and then low points. So this is where we have sinkholes that have connected in certain spots, and we leave these towers or high points of limestone on the surface. And this is actively being eroded both from rainfall and also from groundwater. And then the most developed karst we can see over in China. If you Google or look in your textbook, I believe there's some photographs of karst topography in China. We see these pretty huge mountainous areas, and if you are interested and you turn on photos, let's see here, when we look at some of these, so also these are in Chinese, but some of them show you what the landscape looks like in these areas. Some of them show these features better than others, which is fine. But if you click on a lot of these features, you can see some pretty amazing landscapes. You can see these high points that stick up. And your book has some great photos of this. So these would be considered what are called karst towers. So you can see you have little bitty chunks of that limestone left behind, whereas in the middle and between those high points, all that limestone's been dissolved away. So those are some of the different features, how groundwater moves, how it erodes and creates landforms. We'll come back and talk about aquifers and hazards.